Hey guys, welcome back to coding asteroids in TypeScript. Last time we took a look at point-polygon collisions, and this time we just want to reuse that logic to actually destroy the asteroid. So for our bullet, when our bullet hits the asteroid, it splits into two, and there is some particle explosion behavior. Let me show you what I mean. So in the original game, right? When you see when you shoot the asteroid, it just splits into two, and then you see this explosion effect. Not the ship explosion, but the bullet hitting the asteroid. Yeah, same thing with the saucer ship. I think you will be able to see that here. Yeah, so we're gonna implement that explosion today, and also be able to do multiple hits on the asteroid to reduce its size and eventually make it disappear. All right, so let's jump in. So this is where we left off last time, and let me go back to my code editor. All right, so let's go to game.ts first. Let me just start removing these comments. And what do we have here? Polygon collider. Yeah, so this was just for our debugging. We don't need that anymore. You can get rid of that. And what else here? Yeah, we don't need the debug grid anymore. We can comment that out. We need it later. We can just uncomment it. Okay, so what I want to do here, right? So I want to create a new function called maybe handle collisions. Yeah, so what's gonna happen in here, we first wanna compute, or like we just want to check collisions across all entities, or across all collidable entities, right? And then we want to be able to resolve take action based on the collision, right? Okay, so first I'm gonna say find me all the collisions. So I'm gonna create a new function called check collisions, right? Maybe we can pass in entities, maybe these are entities, and let's create this function. So I'm going to create that function in the collision file. At the bottom here we can say export function. Let's do that at the top. So I want to have these helper functions at the bottom. So I will say export function check collisions. I will say entities. It will be entity collection. All right, so now, since we only have bullets, asteroid, and a played ship right now, and we don't have polygon collisions, we can't really do ship and asteroid collisions. We can only do bullet and ship, and bullet with asteroids. So mainly just the bullet collisions. So let's do that one first. So we will do bullet with asteroid. Okay, you can do for const bullet of entities dot bullets, and then we can go over all our asteroids. And we can say if check collisions, no, we're gonna have a new function called check collision bullet dot collider and asteroid dot collider. Then in here we want to somehow store this collision information, so let's create a new array called collisions, and our check collisions function will return an array of collision. We don't have that type yet, so let's define that. So we will say type collision is equal to, so we can have multiple types of collisions. So for now we can just have one type. Later on we'll just do like a union, and then with the different type marker in here. I can show you what that looks like. So first I will do enum collision type. We can say bullet asteroid and do bullet ship, right? So this way I'm just defining all the collision pairs between different entities, and just making them explicit, and then we can type each like for each collision type we can have a certain collision metadata, right? So we can do the same thing we did for our collider type, right? So if I go back to the collider, we did this enum with the type, and then we just mark this type with that enum type. So that way wherever you use some object and you pass in type collider type, it automatically knows that is the point collider. So that's a trick that I like about in TypeScript. So we can do the same here. We can say type is collision type dot bullet asteroid, get rid of this equal, and then we can say the bullet some bullet, and then asteroid is asteroid, right? And then we can do another one here called bullet ship, and then instead of asteroid we will say ship. That will be the player ship. Do we have ship? Yeah, ship. Yeah, so this way we don't, like we have typed for each event type, right, collision type, we have a specific type of metadata. Now let's first come here and then return collisions to fix the return type, and then in here we need to say array collision. Okay, now in here we will say collisions dot push collisions. I mean we need to create a new collision type. Then we will say type is collision type dot bullet asteroid, and then we will say asteroid is this asteroid, and we will say bullet is bullet. Yeah, so if the name of the key and the value has the same name, you can skip that in TypeScript. So you can say it like that. I don't know, I think it's a bit more readable if you just have that. So I'm just gonna add it back. Okay, let's see, why does it complain here? Collision type is not assignable. Why? Collision type is not assignable to type. Collision type dot bullet asteroid. Why is that? Bullet asteroid. That looks about right. Can I say this is collision? Yeah. Okay. That's what was necessary. Okay, now let's create this function. We'll do it that at here. Export function. I don't think we need to export it. You can just say function. Check collision, and we will say left. We can just say us is collider, and then them is collider, and then I will return a boolean if whether they are colliding or not. Okay, so yeah, so collider has multiple types, right? So we need to first check those types. Yeah, so we will say first if us dot type is equal to collider type dot point and them dot type equals collider type dot polygon, then we can run our point polygon routine. Then we can say return point inside polygon, and then we can say us dot position is the point and them dot polygon is the polygon. Now we need to invert this to say if we are the polygon type and they are the point type, right? Then we can say, just flip this part. We can say us dot them dot point, yeah, position, us dot polygon, right? We can say else if, and we are not going to do point versus point collisions, so we can skip point to point or like a bullet to another bullet collision. We're not gonna need that. We also haven't implemented polygon to polygon yet, so I'm just gonna say return false here for now. Okay, so yeah, this looks okay, and I'm gonna go back here. See, I think I need a new parenthesis. Okay, yeah, this looks okay. Okay, let's go back to our game and let's import this function. I think I forgot one thing. So in here, right, when we find out that there is some collision, we no longer want to involve that bullet in any further collisions, right? Because it's gonna get destroyed as soon as it hits something. So in here we want to basically skip that inner loop altogether afterwards, right? So either I mean, you can just say break here, right? Yeah, that's one way to do it. Another way to do it is to label the outer loop and then say continue outer, That's another way to do it. Just in like, I like this technique as well, because sometimes, like if you're doing row and columns, for example, and you find something in the column and you want to skip the entire row, you can do it with this. But let's just use break. I think it's simple enough to understand. Okay, now let's go back to the game file, and now we want to basically loop over all these collisions. And then we want to check if collision.type is equal to, okay, I think I need to export that enum, here, and then say collision type dot bullet asteroid. Then you want to say we can get the bullet asteroid from the collision. Okay, let's first log something. We can say collision with asteroid. Let's see if we actually see anything. We can say in here this dot handle collisions. Okay, so a bunch of messages. So let me shoot. Okay, perfect. All right, it seems to be working. Let's now actually do what we need to do in order to let's do what we need to do when the collision happens. So what we need to do is we need to remove the bullet first, right? So we can say this dot entities dot remove bullet. So let's give this a try. Okay, perfect. So it's like the bullet is getting engulfed into the asteroid. And then what we need to do is we need to split and reduce the size of the asteroid, right? So what we can do in here, we can just say asteroid dot or we can just have some another function called hit asteroid. I'm gonna pass in asteroid, and let's try that. So we will create this function in the asteroid file. We can say export function hit asteroid. Asteroid is asteroid, and then it will not return anything, so we don't need to specify the return type. Then let's first reduce the size of this asteroid, and then we can say, I mean, if size is below 0, then we need to kill this, right? Okay, we can say if asteroid dot size is less than 0, then asteroid, wait, we gotta do it here. Okay, so we need to remove this asteroid now. So let's pass in our entities here, entity collection, and we will say entities dot remove asteroid. Otherwise we reduce the size, and we need to clone this asteroid because we're gonna split it into 2, right? So we can say child is equal to asteroid dot clone. So we will create this new function on the asteroid. Let's say clone, and it will return new asteroid, which will have this dot position dot copy, this dot velocity dot copy, this dot size, and this dot shape ID. Okay, and then we got the child, and then we need to randomize the child's velocity, because in the original game, what happens when you split the asteroid, one part of it continues on the same path, the other one goes in some random direction. So we will create some random velocity. We can say negatives minus 0.5, because math.random gives us a range from 0 to 1, and then if you negate, if you subtract 0.5 from it, you get a range of minus 0.5 to plus 0.5. We do the same for y component. Then we can say child dot velocity is equal to new vec2 velocity x velocity y. And then we also need to add this child to the asteroids child. Let's see what happens. Let me go back to the game class, import this function, pass in our entities. Let's try it out. It has some error somewhere. And let me just get rid of these extra imports. Okay. Let me reduce the size of the asteroid first. Get rid of this, bring this back. All right, let me try it. Okay, the size does not get reduced. And first, let me go back to the game and give the original one some velocity. Yeah, this extra bullet also in here. Before, let's get rid of that. Now I'm gonna bring this back. Okay, let's see what happens. Okay, size is the same. Or did it change? No, yeah, it is. The size is going down. But it's not going down by the increment we want, right? Because we want the size to be one of these values. Okay, let me create an array here. I will say sizes is equal to asteroid size dot small asteroid size dot medium and large. I think you could also do object or values asteroid size. What does that give? Gives me string as well. Yeah, I don't know. I'm just gonna keep this simple here. So sizes, and then the thing is that this size is supposed to be just some index, right? Not the actual asteroid size. So let's remove that asteroid size constraint here and just take this as an index. So what we will do is we will say wherever it is this dot size, we can maybe just do size and then we can say return sizes list of size. Okay, we're gonna have to rename this. Let's rename this to life. Then I'll do this dot size in here. Okay, let's see it, what happens. That did not work. Why is that? Okay, 0. 2 should be the large one. I don't like passing in the number in here. So I'm gonna go back to Asteroid, and I am going to not use these as values. So I will do maybe just like an index, and in here I will say 2, 5, 8. Were these the values? Let me double check. Yeah, 2, 5, 8, and then yeah, that should be okay. Now yeah, back to this one. Okay, so the size of the child is now correct, but it's moving way too fast. Let's scale down the value. In the hit asteroid, we will say, let's multiply that by, I don't know, 0.4 maybe. Let's try that. Okay, now the original asteroid is not getting updated. I think it's because we have a fixed set of vertices, and every time you hit the object, hit the asteroid, we need to recalculate the vertices. So maybe I will create a new function here. I will say update geometry, and I will do this part. And then in here I will say update geometry, and then in here I will say update geometry asteroid dot update geometry. Say this dot vertices goes to an empty array. Let's try that. Okay, looks good. I don't know if the speed of the child is supposed to be faster. I think so. So every time you split it, it goes a little bit more fast. So maybe we can do something like 1 divided by asteroid dot size right? So that way we scale it appropriately. Well, it needs to be no. So the bigger the asteroid, the smaller the speed. That looks correct. Why is it so slow though? Or maybe we just need to tune it. So we will scale it by some predefined constant. Maybe we can say 5. Okay, that's way too fast. Maybe we can say 3. That's still too fast. Okay, I mean the small one is going way too fast. So maybe I won't use the size, but I'll use the life instead. So it doesn't grow that fast. Right? And I don't want it to be 0 here. Okay, let's skip this part for now. We'll come back to these tweaking things. Let's just leave the velocity at 0.5, see where it goes. Let me just kill this asteroid. If I can point the ship at him. Okay, going way too fast. Just gonna scale it down a little bit. I'll say 0.5. Okay. Yeah, this looks okay. I'm gonna leave it at that. I don't think we're gonna have time to do the explosion effect today because it took pretty long to do this basic stuff. But at least we have the like a nice mechanic here, right? We can shoot them. Let's see if when you hit the last one, if it actually gets destroyed or not. Yeah, it does. Perfect. I just am moving way too fast. What if we just calculate some random direction only? So we can say dx, dy, and we can say constant dir is equal to new vec2 dx dy, and we can normalize it. Okay, we need a new function called normalize. we can say normalized, and it will return a new vec2. That will be return new vec2, and it will be const mag is equal to this dot magnitude, this dot x divided by mag, this dot y divided by mag. Yeah, so this will just give us a unit vector, and then we can take the original velocity and then we can scale it by I mean we can take the original velocity and just point it towards that direction, right? So we can just do this instead. Child dot velocity dot x is equal to child dot velocity dot x into dir dot x. Yeah, that's fine. So this way we are just changing the direction but not the speed. Yeah. Okay, looks good. All right, I think I'm gonna end the video here for this part. We can take a look at the explosion next time. But this I mean already looks pretty good. Looks like you can shoot around, you can, I mean the ship goes way too fast. I need to tweak around these numbers somewhat. You can do that in some polishing episode, but still at least you can shoot around some asteroids. Okay, thanks for watching guys. I'll see you next time.